examples, we'll introduce a couple of measurements that are associated exclusively with curvy things like circles, and that's going to be arc measure and arc length. So let's look at example 5. A steaming Italian pie with a 12-inch diameter is sliced into 6 equal pieces. Look at those pizza slices, like each one's a different flavor. It looks really good, it looks delicious. Except for the meat on this one. Anyway, what is the length of the crust on each of those pieces? So for example, let's assume I'm the type of person who eats all of the delicious pizza and then leaves behind the pizza crust. First of all, like why? Why are you wasting good pizza crust? Second of all, like we want to know all that pizza crust that you wasted, how long was it? How much did you actually throw away? Well, does it make sense that that pizza crust, the crust that's on one of those pieces of pizza, is just like some fraction, some portion of the whole entire circumference of the circle? And specifically in this case, each one of these pieces is 6, so it's like what I could do, strategy-wise, is I could find the circumference of this whole entire circle, and then I can divide it into 6 pieces, right? Or I can think of it as 1/6 of the whole circumference, because dividing by 6 and multiplying by 1/6 means the same thing. So what piece of information do I need to find the circumference of a circle? I need either a radius or a diameter, and I just happen to have a diameter of 12. So the circumference is supposed to be pi times my diameter. My diameter is 12, so I have exactly 12 pi, throw some inches in there, for my circumference. All right, and now we talked about our strategy for the piece of pizza crust that we are throwing away and trying to measure. I'm going to take the 12 pi and I'm going to divide it by 6 right there. So I'm going to call that arc length. Arc length is equal to, what was it, 12 pi? Yeah, it was 12 pi divided by 6. I can take the 12 divided by 6 to get exactly 2 pi inches. And that's how long one of those pieces of pizza crust would be. That is an example of finding arc length. All right, if we look at this next slide here, you can see that an angle is being measured here because it has 60 degrees in it. It's the tip of this piece of pizza that's right here. Now this pizza slice, it's not exactly a triangle because it has this curved edge that's right here. The specific name for that shape is called a sector. And I bring this up because the tip of this that makes an angle, it shares the center of the circle. The vertex of that angle shares the center of the circle. If I draw a circle around here, angle AOB is the one that measures 60 degrees, and there's a special name for that type of angle. It's called a central angle. Well, that should make sense because the vertex is the center of the circle. So a central angle consists of 2 radii, that's OA and OB, and the center of the circle. It's measured in degrees. I can measure with a protractor if I wanted to. So this one I didn't have to measure with a protractor because all the way around the circle is supposed to be 360 degrees, and there are 6 equal slices, so 360 divided by 6 gives me 60 degrees each, right? All right, now then let's talk about, oh, look, right down here at the bottom, this is the proper notation for the measure of an angle. I put an M in front of the angle name. M means measure of angle AOB. O is the center of the circle. It's also the vertex. It's the one that has to come in the middle, is equal to 60 degrees. Okay, so the next thing we'll talk about is specifically the arc measure. The arc measure is the measure of the central angle that it intercepts. Since it's the same thing as the central angle, it must also be measured in degrees. It's the amount of rotation from point B to point A. It's not how long it is. That's something different. That's called the arc length. So the arc length is just a portion of the circumference of a circle. It would be measured in inches or in centimeters. It's measured in linear units. So let me show you the difference between these two things. Back here on Notability where I can draw on it, I'm going to select a red crayon and I'm going to make it husky. Let's make it husky like this. So watch what I'm about to do. I'm going to draw in a radius here from O to B here. And arc measure is how much I have to rotate from B to get to A. It's not how far I have to go, it's how much I have to rotate. Let's say that my head is situated at point O, and I'm looking over here at point B. Arc measure is how much I have to rotate my head, turn my head in order to see point A. Rotation is associated with angle measurements, and it's also associated with the measure of the arc. And that's different from the length of the arc. So for the length of the arc, let me choose a blue crayon this time. Let's assume that a fly got into the room and it landed on this piece of pizza right here at point B. And arc length is how far does that, oh, it's going to turn into a straight line? Okay, fine. How far does that fly have to walk along that pizza crust? It's basically the example that we just worked right up here. What it was asking us, what is the length of that piece of pizza crust? That's arc length. And that's the difference between those two things, arc measure and arc length. Let's take a look at example 6. Assume the radius of each circle below is 24 units. Find the length of arc AB. So let me come back over here 1,000 more times. And it says that, I'm going to actually shrink this down to a normal size crayon right there. The radius is 24 on each of these. Okay. And notice that I have angle measurements here. If I put an O right here, this measure from B, O to A, that's a central angle. It measures 90 degrees, but that's also how much rotation there is from point A to B. That's the measure of the arc. And I'm going to use that angle measurement to help me figure out the distance, the length of the arc from point A to point B. It's associated with 90, but 90 degrees is not a length. It's how much I have to turn to get from one side to another side. So think about this. This is 90 degrees out of how much? It's 90 degrees out of 360, which gives us a fourth. It's basically 1/4 of a circle. So if I find the circumference of the circle, all I'd have to do is take 1/4 of it, or divide it by 4, same thing. To find the circumference of the circle, since I'm given the radius here, I'm going to use the formula 2 pi times r, where my r is 24. 2 pi times 24. I can multiply that in any order, so I'll just go ahead and multiply the 2 and the 24 to get 48 pi, and this is in units. There's the whole entire circumference. So for the arc length on the first circle here, it's going to be 1/4 of that. 1/4 of 48 pi. This is the same thing as 48 divided by 4. It leaves 12 behind. I have 12 pi units. It's a length. It gets units. It doesn't get degrees. Okay, let's look at the one that's in the middle. This looks very familiar. This is 60 degrees. We already know that's 1/6, right? Because it's 60 out of 360. That gives me 1/6. So I'm going to take the same circumference and this time multiply it by 1/6. 1/6 of 48. 48 pi. What is 48 divided by 6? It leaves an 8 behind to get 8 pi units. And then lastly, our arc measure is 45 degrees. And 45 is, let's see, 45 out of 360. This time is, I think it's, is it an eighth? 1/8 of that pizza? Let's see, 4 times 8 would be 320 plus another 40. Yes, that makes sense. It's 1/8 of that whole entire pizza or circle or whatever it is. In this case, it's 1/8 of 48 pi for a total of 6 pi units for the arc length right here. Which brings us to a formula for finding the arc length. If the radius of a circle is r, and two radii form a central angle of a degrees, as we can see here, a degrees here, then the length of the arc formed by those radii is given by the formula. It says arc length of AB, and I put a little mustache on top of this to indicate an arc here, is equal to the measure of arc AB. That's this a degrees that's right here. I'm going to put that as a degrees. Out of 360 times 2 pi r. 2 pi r, of course, is the circumference there. Isn't this the exact same formula that we are basically developing back here on these questions, we took a fraction and multiplied it times the circumference, 2 pi r. That fraction was reduced, but look at what it was. It was 90, that's our angle measurement, out of 360 degrees. So that's how I find the arc length. Now I can rearrange these pieces. I can actually take this 2 pi r right here and I can bring it over to the left-hand side by dividing it, and I turn this thing into proportion. So depending on what it is that you're looking for, sometimes solving this proportion is a little bit more of an advantage. We have arc length of AB over 2 pi r, so we have a length over a length is equal to the A degrees, the measure of the arc, over 360. So you want to keep it consistent. We have length over length, and we have angle measurement over angle measurement.